Hey, this is Mr. Coker with Foundations of Algebra, Lesson 4.1, Combining Like Terms. Combining like terms is fairly simple. However, it is one of the most important things that we'll learn in this class. So, let me start by talking about what a term is. If you look over here, you see examples. It says terms 2x to the second power, also known as 2x squared, plus 5x minus 7. A term it's some combination of letters and which are called variables and numbers that are separated by either a plus or a minus sign. So in this example, 2x squared is one term. Even though there are two different numbers and a variable, it's one term because it is separated from the others by a plus sign. 5x is a term, and that is because, again, if you look on both sides, you see a plus and a minus sign. 5x stands for 5 times x, but multiplication doesn't separate two items from being one term. Only a plus or minus sign does that. And then the last number is 7. It's minus 7, which is a constant. A constant is a number in an expression or an equation that does not have a variable associated with it. So it's not being added, it's not being either multiplied or divided by a variable, or put to the power of a variable. So, combining like terms. We have this big, long, weird-looking expression. 3x squared plus 5x minus y plus 7 plus 2x squared minus 3x plus 8 minus 2y. So what we have here is a big old collection of probably what looks like nonsense if you're not used to like two combining like terms. But if you look at this, you'll see that each term has something about it that is different from at least most of the others. Combining like terms is just what it sounds like. It's taking terms which are alike and adding them together, or subtracting. So, what is a like term? A like term it's any term that either has the same variable and the same exponent or has no variables. So, for example, I mentioned minus 7 being a term. If we had another regular number, we could just a constant, like say 8, we could add that. We could combine two constants. So we can also combine anything that has both the same variable and the same exponent. So let's get started. I'll start at the top. We have 3x to the second power, 3x squared. I'm going to underline this in red, and then I'm going to look for any other terms that has both an x and to the second power. It's got to have both. So I can look and I see 5x. Well, that has an x, but it isn't to the second power. So that is not a like term. I have a y, a 7. Neither of these have an x at all, and certainly not to the second power. Next, I have 2x to the second power. Well, that one can be combined because it's got both an x, it's got an x to the second power, an x and it's to the second power. Those are like terms. Here we have a 3x, and you notice we have 3x squared and here's a minus 3x. Those are not like terms. A lot of times students get those confused. Try not to get that. Just don't worry about the coefficient. The coefficient, of course, is a number in front of the variable. It's how many times the variable is being multiplied. Don't worry about the coefficient. Only worry about what is being, whether or not it has the same variable and the same exponent. So then we have an 8 and a negative or minus 2y. So those are our only like terms of x squared. So next I go to x, do 5x. Well, 5x, if you look at it, what else do we have? What other x's? Again, we have the minus 3x. So I'm going to underline that twice and go down. And that's our another like term. Next I'll go to y. I'll underline this one in whatever color this is going to turn out to be. Oh, in no color. That marker is dry. So I'm going to underline the y's 3 times in black. And so here we have, and by the way, this is going to be important when we combine them in a moment. I'll explain what do you do if you just have one y, if you have just a y. So then we have constants. So with the constants, again, that should be hopefully something that will kind of trigger something in your memory a little bit, that if you have just two numbers like 7 and 8, you know that you can add those together. Or in this case we have a negative 7 and an 8, but you know you can add those together. They're just numbers, they're constants. The same thing applies to terms like 5x or 2x squared. Just add them together as if they're regular numbers, and I'll show you what I mean. So I'm going to bring all of these down. I'm going to start with my x squareds. I'm going to put 3x squared plus 2x. Now I'm going to put that in a box. Usually I only like to box in my answers, but in this case I'll make an exception. Oh, that's a 2x squared. Very important. So I'm putting these together in a box. Next I'm going to do my x's, my just x's, 5x plus or minus 3x. Now, very important. If it says minus 3x, you're going to do minus. You're not doing plus. It's a negative 3x. I'm going to box that in. That'll be my x box. Next, I'll do my y's. I'm still going to put a plus, but then I'm going to put negative y minus 2y. And finally, we're going to take our constants. We have 7 and 8. Oh, it was a positive 7. So, I've put each of these in its own separate box in a different color to make it visually, hopefully visually, a little bit easier to comprehend. So, I'm going to start with my x squared box. My answer is automatically going to be some number of x squareds, because this is what we're adding. We're adding 3x squared plus 2x squareds. What we're really doing is taking 3x squareds plus 2x squareds. How many do we have? 1, 2, 3, 4, 5. 3 plus 2 is 5. If I write them all out, I also have 5. And that's our first term, our first combined term. Now we have 5x minus 3x. Well, what's 5 minus 3? 5 minus 3 is 2, so we're going to have plus 2x. Let me show this visually. So if I have 5x's and I'm minusing 3x's, I'm not even going to write it out like I did over here. If I have 5x's and I'm minusing 3x's, well, 1, 2, 3. How many do I have left? Of course I have 2. Next we have negative y minus 2y. Sometimes people get confused when you don't have a number in front of a variable. Well, when we don't have a number in front of a variable, what do? Well, we put a 1 in front of it. Or we assume there's a 1. You don't have to write the 1, but know that there is a 1 in front of it. And this is one way to think of this. Well, if I have, and I'm going to put a negative because it's negative, I have a negative y, right? That's what it says, it's a negative y. And I have I have negative 2y. Well, that's 2 more negative y's. How many total do I have? Negative 1, negative 2, negative 3. Well, it's fitting because negative 1 minus 2 is 3. Again, we can add the coefficients. Finally, we have 7 plus 8. Well, 7 plus 8 is 15. That one should be simple because it's a regular number. It's 2 regular numbers, 2 constants. So, this is the final answer. This whole thing I boxed in is the final answer. 5x squared plus 2x minus 3y plus 15. Now, why is that the final answer? Well, sometimes people won't add those together. They want to do like 5 plus 2 minus 3 plus 15. You get what, 17 on that one? 19. 19. Okay, so a lot of times people won't do that, and it's understandable because in math we're used to dealing with numbers and having a number, an answer that's just a number. Combining like terms and a lot of the types of problems that we do in algebra are not like this. So the reason this is our final answer is each one of these terms cannot be combined. We have x squareds. We don't know what x squared equals. We have x's. We don't know what x equals. We have a y. We don't know what y equals. And we have 15. We know 15 equals 15. However, we can't add any of these together because the variables are different. We'd be counting different things. It would be like if this was apples and this one was oranges and that one was like raspberries or something. We can't add those together. They mean different things. It's the same reason that we can't add together fractions that have unlike denominators. So when you get to this point, know that your answer is done. Your problem is done. And you don't need to go any further. So this is combining like terms. If it seems complicated, hopefully it will be, you'll see with practice that it really is simple, but again, although it is fairly simple, it's extremely important in algebra. So, thanks for watching and have a nice day.